So typecasting is an interesting topic in computer science. The reason it's interesting is because there's a lot of nuance around it. There's a lot of different types, and the rules for like compiled languages and interpreted languages might be slightly different. Like different languages might have typecasting, but what that actually means can differ between the languages. So I can give you like a quick a guide on typecasting. So if I were dealing with a language like, let's say, the C programming language, you can have like implicit casts and explicit casts. So an example of like an implicit cast would be, I have an integer, 32-bit integer, and it stores some number, and there's a function that takes a 64-bit integer. Maybe it's like defined as it takes a double, and I have an int. I can safely pass that int into the function that takes a double. An int can be implicitly cast into a double without any issues. A 32-bit number can fit comfortably in a 64-bit number without any sort of data loss or anything like that. Going backwards becomes problematic. If you have a 64-bit number and you want to cast it to be a 32-bit number, you have to explicitly do that. That can't be done implicitly. You have to explicitly do that because data is going to be lost there. Potentially data will be lost there. You might have truncation of the other bits. If you know you're only fitting 32 bits in there, hey, good for you. But that's where you, the programmer, have to come in and say, hey, I know what I'm doing here. I might incur some data loss. That's totally fine. So yeah, it's sort of like, I think of it like a square and a rectangle. If I have a function that takes rectangles and I have a square, that rectangle function is totally fine. A square is a rectangle. But if I have a function that expects a square and I have a rectangle, I can't really put it in there unless I know my rectangle is also a square. So that's kind of how I separate those two there. Beyond that, like if I'm dealing with like C with pointers and stuff, typical thing that I'll see is there'll be like some function or some library I'm using where you can register like a callback function. And one of the things you can register with it is arbitrary data. So I can basically say like, hey, here's an example. I want to watch this file on the file system for changes. And when this file is modified, I want to be alerted. I want you to call this function when that happens. You can give it arbitrary data. And then when that library calls your function, it gives you back that data. So you can sort of mark the file or do whatever you want. It doesn't matter what that data is. Typically in that kind of implementation, it will take a void star. It'll just be a pointer to anything, just any pointer. So me, the programmer, I know what type of data it is. Maybe I've created my own struct. I have my own struct called my data type. When I pass it to that function, you might see me cast it as void star. That way the compiler doesn't yell at me. And then when I take it out of the function, I recast it as my struct type. This is telling the compiler, hey, for all intents and purposes, I know this pointer is this type. Treat this pointer like this type. And then at runtime, if it's not that type, things are going to blow up. We're going to have some weird behavior. But yeah, so typecasting in that specific instance is more like me, the programmer, who knows a little bit more than my compiler, saying, here's how to treat this data.